Okay, so what we did in the previous video, which probably was very excruciating, is that we calculated the gain, right? V out over V in. And when if we calculate V out over V in, and we got this equation, and what I did was I substituted S equal to uh, 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 j omega, right? Which was the substitution that we did in the previous video when we were calculating S equal to j omega, or omega is the angular frequency, so it can also be written as j 2 pi f, and that's what I've done. And if you do that, you get this equation. Now, so this is the input output relationship of this filter. Now, if you want to look uh, at the filter characteristic, just to understand it, uh, there are three parameters that are involved with a second order filter, and those parameters are in this equation. One is k, which is the gain of the filter. F naught is the cutoff frequency of the filter, and Q is called the quality factor of the filter. So K, F naught, and Q kind of define the behavior of the filter. And for a second order low pass filter, the general equation in terms of K, F naught, and Q is given by this equation. Just take it as a given for now, okay? And if you want to calculate then, given these parameters, if you want to calculate what the values of K, F naught, and Q are, you can do that. And I'll leave you to work it out. And what you would find is that you get K equal to 1, okay? And you get F naught, which is the cutoff frequency, equal to 1 over 2 pi RC, and you get Q equal to 1 over 2. Okay, so those are the parameters that we get for this particular filter configuration. And so what does a second order filter look like? Low pass filter look like? It has a cutoff frequency of 1 over 2 pi RC, which was the same cutoff as the first order filter. It has a gain of 1. And then what it does is the slope of the second order filter, as we discussed a few videos back, is not minus 20 dB per decade, but because this is a second order filter, we get a slope of minus 40 dB per decade, right? Uh, okay, so what I've done is, so in this case, what I have assumed is that these two resistors are of the same value, and these two capacitors are of the same value, right? I just did that because it makes the maths a little bit easier. But you could do the same problem with these two resistors taken separately and these two capacitors taken separately, and that would be solving a more general problem. Also, you could add a gain, right? So this connection from the output to the inverting terminal is very similar to the connection of the voltage buffer, right? You can add a gain uh, to this setup by having a resistance here in the feedback loop and having a resistance here going to ground. And let's say this is R3 and R4. In that case, you are adding a gain of R3 over R4. So you could, or it's actually 1 plus R3 over R4. So you could do add the gain as well to the filter. Now, this general the derivation of the output of the general filter is given in the notes, and I have just put the file below on Moodle, and you can take a look at that.